Welcome to AI Podcast. I'm Ethan. Today we're unpacking an ACL 2025 paper titled Agentic Reasoning. In one line, the authors show that giving a reasoning model three focused helpers, web search, a coding agent, and a structured memory called mind map, can markedly improve performance on hard research-style problems. With DeepSeek R1 as the base, accuracy on humanity's last exam rises from roughly 9% to just under 24%, which puts it close to leading proprietary deep research systems.
I'm Maya. That's a strong headline. Who led the work?
The paper is led by Junde, with collaborators from the University of Oxford and the National University of Singapore, alongside partners at Carnegie Mellon University and MBZUAI. The corresponding author is Yueming.
All right. Before we get into the mechanics, what problem are they trying to solve?
Large reasoning models do well on math and coding because those answers are easy to verify. But real-world research questions are messy. You often need to search the web, cross-check facts, run small calculations, and remember what you figured out earlier across a long chain of thought. The gap is letting a model use outside tools while staying coherent over long sessions.
And what had people tried before, and why wasn't it enough?
Open research typically added a single capability, like basic retrieval augmented generation or simple web search inside the chain of thought. Helpful, but still behind closed systems that coordinate multiple skills. There's also a trap. Throwing a big toolbox at the model can backfire because it starts choosing the wrong tool at the wrong time. Quality and coordination beat sheer quantity.
So what's their approach exactly?
They keep it tight and deliberate. The reasoning model can insert special tool call tokens mid-thought to trigger one of three agents. First, a web search agent that breaks a vague query into sharper subqueries, runs search, re-ranks results, and distills a short, readable snippet before handing it back. Second, a coding agent that executes code outside the main model and returns a natural language summary of the result. Third, mind map, which turns the ongoing reasoning into a knowledge graph so the model can retrieve what it already deduced and keep long chains coherent.
Mind map sounds like a whiteboard for the model. Why is it so helpful?
That's a good way to think about it. Mind map keeps track of entities and relationships, reduces drift, and supports questions that need extended reasoning. In one social deduction test, the presence of mind map roughly doubled the model's win rate, which is a neat signal that structured memory can help with strategy and logic, not just facts.
Nice. How did they set up the experiments?
DeepSeek R1 is the default backbone, and they also plug the framework into QWQ to show it transfers. The web search stack uses Bing to fetch pages and a re-ranker before retrieval and summarization. Mind map construction and graph-style retrieval run with DeepSeek v3. For coding, they use Claude 3.5 Sonnet with execution in Python and send back only human-readable outputs. Generation uses a large context window with standard decoding, and results are reported in Passet-1.
And how did it perform?
On humanity's last exam, accuracy climbs to about 24%, a jump of over 14 points versus the base model and close to OpenAI's deep research result. On the GPQA graduate-level science benchmark, the framework outperforms earlier search-in reasoning methods and even edges O3 mini high when paired with DeepSeek R1. On the Gaia agent benchmark, it sets a strong public result overall, ahead on the easier levels and only a little behind on the hardest. For deep research writing, it leads on Rouge and entity recall on FreshWiki. And in a study with 56 expert questions, human raters favored its articles for organization and relevance.
That's encouraging. Did they run ablations to see what actually matters?
They did. 3 lessons stand out. 1, tool quality matters more than having a lot of tools. 2, the trio is synergistic. Web search plus mind map or web search plus coding helps, but all 3 together work best. 3, search design matters. breaking down queries using a strong re-ranker, and conditioning on mind map context, each adds measurable gains.
All right, now the practical concerns, what are the caveats?
Chaining search memory and code adds compute and latency, so this shines on deeper tasks rather than quick chats. Because it leans on web sources, reliability and bias need attention. The paper suggests trust-aware checks as a next step. Reproducibility is generally good. The code and data are public. But some components are commercial services, so exact numbers may shift as APIs change. And the human study is informative but still small, so broader evaluations would help.
If someone is deciding whether to try it, how would you summarize the value?
If your work involves genuine digging, searching, cross-checking, doing quick calculations, and weaving everything into a coherent narrative, this small, well-chosen tool set delivers much of what people expect from fully proprietary deep research systems. The key is disciplined search orchestration and a memory that keeps the reasoning stitched together.
And where does this line of work go next?
Smarter scheduling so the model knows when to call which agent, trust-aware retrieval to filter noisy sources, richer memory that detects contradictions and timelines, evaluation across more backbones and multimodal tasks, and clearer human-in-the-loop controls for high-stakes domains like medicine and law.
Great, thanks, Ethan. That was clear and grounded.
My pleasure. That's it for today's AI podcast. The paper is Agentic Reasoning by Junde and colleagues presented at ACL 2025. See you next time.